Hello everyone who's just joining us and welcome to our webinar on the climate impacts of plastics consumption in Australia, which is a special briefing on new research that's just been launched by AMCS and WWF Australia. Now I'm just going to give it a couple of moments before we start and do some introductory comments as people filter in. I can see we've got participants quickly jumping on, which is fantastic. So first up, I'll note that this webinar will be recorded. So for anyone who has to drop out during the webinar or who hasn't been able to make it today, we'll be popping that up on the AMCS YouTube channel next week. I also want to just acknowledge the land and sea countries on which we're meeting. Today I'm chairing from the land of the Yagara and Turrbal people in Brisbane, otherwise known as Meanjin. And I want to pay my respect to the elders past, present and emerging, and acknowledge that land and sea country was never ceded, and that this year is a very important year as we work towards hopefully achieving a voice for Aboriginal and Torres Strait Islander people. Now, for this event, we're going to have Kyle talking us through the research that's been released and going in depth into a bit of the modelling behind and how that happened. Kyle's the report author and works at Blue Environment as a director. And then afterwards, we're going to go to Kate Noble from WWF Australia, who's going to talk to us a little bit about the policy implications of the research. After that, we'll have some time for a Q&A. Now, if you have questions during the webinar, there is a Q&A button that you can use to pop your questions in, and that'll allow us to be able to sort through the questions and pull out those that we can jump to at the end. But we've also got the questions that were submitted in advance of the webinar. So we've got a selection of questions that we'll go to that have already been submitted. If you do have any technical issues, AMCS staff, Tara and Jess are also on the line, and they'll be able to respond to your queries. And you can use the chat function to message the panelists and Tara and Jess if you need assistance, and they'll be able to help you out with giving you links to where you can get technical assistance if you need it. I think that's pretty much it. So without further ado, I'm going to pass over to Kyle, who's going to give us that summary of the research.
Yeah, good afternoon, everybody. Yes, I'm Kyle O'Farrell. I'm a director at Blue Environment. We're an environmental consultancy that does a lot of data, in particular related work around recycling and waste recovery in Australia, or management, and also greenhouse gas related work and resource efficiency type work as well. So this study, carbon emissions of plastics of Australian plastics. We in this, if you can just go to the next slide, Shane. So in this, so AMCS and WWF scoped and commissioned this study, and we undertook it, obviously. So what the overall study does is basically breaks up plastics flows through the economy into four areas, which is plastic production, product manufacturing, use, and end-of-life management. And the study, I'll go into a bit more detail on this later, but the study then modelled 5 major polymer types through those four stages, and in 2 of those stages, so product, polymer production and end-of-life management, we also modelled multiple different sources for polymer production, and for end-of-life management, multiple different fates for the plastics as well. So that's that first dot point you can see on the slide there. So basically, we set up a group. We modelled 56 different processes across the 5 polymer types, and those each process was based on 1 tonne of each of the polymer types having to travel through that point of its life cycle. And then what we did was, once we had that greenhouse gas modelling on a per tonne basis at each of those different stages for each of the different polymers, we then mapped that per tonne data onto data that was available on projections on plastics consumption, plastics going to use, and plastics reaching end of life, so having to be managed as a waste or recovered. And that data was projected out to 2050. And so we took those per tonne emission factors for each of those different processes that we modelled, and then constructed 11 different illustrative scenarios to sort of tease out what the different aggregated emissions would be out to 2050 for each of those scenarios. Do you mind jumping to the next slide, Shane, please? So the study was a bit unusual in the sense that it first of all, it modelled plastics use on a per tonne basis, and usually life cycle assessment or carbon footprinting is very much on a product or service level. So, but for the requirements of this project, we had to bring everything back to a mass basis so we could map it onto the consumption and end of life generation projections out to 2050 that I mentioned. But as much as possible, we tried to align it with the ISO standard 14067. And although it's pretty silent on, it doesn't have any, it's, as I said, very product related, and it's silent on how to do projections over time. It doesn't have a time element in it, largely. Just in terms of nuts and bolts, we did those emission factors, those 56 processes that we modelled. They were modelled in OpenLCA, and that's a life cycle assessment modelling software package, and that draws on inventory data sets, which are a separate thing. And the inventory data sets we used were Eco and Benton AusLCI, as they were the most, they were the best ones that we identified. But we also, just due to the nature of the study, because some of the processes we had to model, such as like the chemical recycling of PET or the production using biomass of PVC, they don't exist as such, or they don't exist. So we had to build those up, which is all documented in the report, in the modelling, and we didn't have pre-existing inventory data to draw on. But what the inventory data, those two inventory data sets do provide are things like, how carbon intensive is electricity in China. So if resin's being made in the US or China, we have those pre-existing carbon emission factors to draw on for electricity, international transport by ship. That all comes out of that pre-existing inventory data set. So the work was, as much as possible, we drew on the pre-existing processes, the pre-existing emission factors that we could draw from those two inventory data sets, but we had to do a lot of, building of processes and calculation of emission factors as part of the project. And so then what we did, we had those 56 emission factors, and then we just put those into a Excel model that we built, and then that enabled us to map those emission factors onto the plastics consumption, end of life generation figures that I mentioned, which came out of the Australian Plastics Flows and Fates study, and also build the scenarios that we have in the report as well. And that's and that's sort of just an overview of what the modelling framework looked like. Can you jump to the next slide, please, Shane? So yeah, as I mentioned, we modelled PET, polyester, HDPE, PVC, polypropylene, and polylactic acid, PLA. Those 5 polymers, or it's pretty much the first 4 because there's very little PLA used in Australia, but those 5 polymers represent outright 54% of plastics consumption in Australia in 2020 financial year. LDPE, which is plastic number 4, very similar to HDPE in terms of its carbon emissions associated with its use, production. I think that if you included that pushes the modelling coverage up to about 70 odd %. And But just to back up a little bit, so we modelled 54% of plastics use in Australia. For the other 46%, which was mainly LDPE, a little bit of polystyrene, which is about 5% of consumption, or 4%. It's actually surprisingly little. And then just a whole raft of other, more obscure polymer types. Starting, things like nylon and polyurethanes. Which we didn't model, just didn't. Maybe in the future, but not as part of this. So what we did to estimate the emission factors for all the other polymers, that other 46%, is we looked at the, which polymers did we model that were the best proxy for those other models. So for LDPE, obviously the best proxy is HDPE, very similar. Things like polystyrene, we looked at the carbon content of that and the production processes, and it was, probably fairly similar to HDPE as well. So we just adopted the factors for polystyrene adopted the factors for HDPE for polystyrene, and then we just went through the list and made those allocations. Just in a bit more detail on the modelled systems. So this is where we were modelling, as I mentioned, at four different stages, and you can see that polymer production, it had four different sources of carbon effectively going into the resin that was being produced. Product manufacture, that was built up on a per polymer basis. So there was only one process for each polymer in that, but they had different allocations of those 7 types of conversion process that could be applied to the resin to convert it into a component or a product. And it's all detailed in the report. The product use, it's identical for, there was no real differences modelled there. It was really just a bit of transport allowance. So we didn't include things like electricity for running a computer, or or for running a fridge, or for driving a car, that sort of thing, or fuel for driving a car. Product end of life, for each of the 5 polymers, we modelled each of those 6. Composting was only PLA because only it can be composted. We modelled those end of life fates. So PET was modelled as being able to, what's the carbon emissions associated with mechanically recycling it? What's the carbon emissions associated with chemically recycling it? Not composting. What's the carbon emissions associated with burning it and recovering some of the energy and exporting it as electricity? What's the emissions associated with just straight incineration with no credit for any energy export? And what's the carbon emissions of just sending it straight to landfill? And so that's how we built up that grid of carbon emission factors per tonne by polymer type across all those different processes. Next slide, please, Shane. So this is what it looked like on a 20-year basis. This is the carbon emissions for each of those discrete processes for each polymer. And you can see, and this is based upon, so in the modelling, all the processes were modelled as if at the current energy supply. So what's their status quo? What's the carbon emissions associated with that process right now? Whether or not it's a real process or a theoretical one, because we've got the CO2-based production processes in there based upon a current energy supply, which don't look very good. And so these are for each of those processes with really almost no credits or anything involved except for the energy recovery processes you can see there, which do already have an electricity credit built into them. These emissions are what the atmosphere sees. And so by doing it, really discreetly like this, that's how it gave us the flexibility to be able to map it onto the projected flow data that we had out to 2050 and build up those comparative flows. There's lots of detail in there. You know, one interesting thing is, you know, how for me was, you know, how apparently how poorly CO2 based plastics looks, but that's because it's very greenhouse gas intensive to create hydrogen, which is one of the inputs that's needed for that from methane. What else is interesting? You can see that energy recovery and incineration, you know, they're effectively the same thing, except energy recovery gets that credit. So you can see that there is actually quite a noticeable electricity export credit that energy recovery can receive. But of course, yeah. But of course, that actually decreases as the other energy supply, electricity supplies into the grid mix become more renewable. So the credit for that, the credit that energy recovery receives goes down over time. Yeah, I think, yeah, just jump to the next slide, Shane, please. And so here you can see it looks very different under all those 56 processes when modelled with 100% renewable energy supply, like an idealised supply, which has the carbon emissions of about 5%, you know, just averaged across all the different energy inputs of current energy supply. You can see that it looks very different. So polymer production from fossil sources drops a little bit, but not very much. And that's due to the assumption in the modelling that the upstream energy inputs into making fossil carbon-based plastics won't change much, because, you know, if a refinery has hydrocarbons going into it and it's burning some of those for energy, it won't stop doing that, because they're the products it has there, and, you know, there won't be new refineries that somehow don't use low value or waste hydrocarbons for energy. Probably the biggest obvious jump there is how you know, the improvement in the CO2 based carbon emissions, and that's almost entirely because hydrogen, the hydrogen input into that process, if it's generated from fully renewable sources, has a dramatically smaller carbon emissions associated with it, and it actually ends up with credit, because that CO2, which would have otherwise gone to atmosphere, gets bound up in the plastic. You can see that energy recovery and incineration are much closer in performance. So the rest of the grids are assumed to be renewable, and so any electricity generated from energy recovery is effectively pushing out at that point other renewable sources, so it no longer gets a credit. And things like the mechanical recycling is a good one to have a look at. That, you know, that drops dramatically, because mechanical recycling, which largely, you know, involves chipping, you know, sorting, chipping plastics, washing it with hot water, for example, drying, etc., is relatively easy or straightforward to shift to 100% electricity-based inputs, and if they're all renewable energy based, then it starts to look very good. Just next slide, please, Shane. So we set up what we call in the report, you know, like 11 scenarios to sort of explore the emissions landscape of what when we took those emission factors per tonne, mapped it onto the projected plastics flows out to 2050, and then built these scenarios using various assumptions around how much plastic was going into use, and you know, and where it was going at that end of life, how it was managed. These 11 scenarios were chosen to sort of, you know, give a picture of that. You can see there's 4 related to just, changing consumption, holding it flat, or up to dramatic drops. Just a scenario 4 is an interesting one. It's just assuming that we continue with current levels of consumption and projected increases in growth in consumption, but we just shift by 2050. So that's not an instantaneous drop from the scenarios. Don't assume an instantaneous change to those states by 2050. They either assume a linear change or there's some complexities to that. Yeah, we assume that it's a 100% recovery rate by 2050, which means, for example, the current recycling rate of plastics in Australia is about 13%. So that means that by 2035, that scenario assumes that the recycling rate would be possibly around 40%, something like that. And then over the following 15 years, it just continues increasing to get to 100% only by 2050. Yeah, plenty of detail in there. Yeah, next, Shane. Sorry, next slide, please, Shane. Yep. And so here's what those 11 scenarios look like. And this is on a 20-year global warming potential basis. You can see that the business as usual scenario, so across the 30-year time frame of the modelling, that will result in about 850 megatons of CO2 emissions, which is just trying to, it's a few percent of total carbon emissions by Australia each year. The flat consumption, just by holding consumption, no other changes, not shifting to renewable, more renewable energy inputs, not increasing recycling, just by holding consumption to the current level, that provides that dramatic drop in CO2 emissions. Increasing falls in consumption, providing incrementally improvements in the overall carbon emissions. 50% recycling recovery rate by 2050, only a little drop from the 850 business as usual. Look, and the reason for that might seem counterintuitive. The reason for that is that that's a 50% recovery rate by 2050. So, that's possibly a 30%, assumed a 30% recycling rate, recovery rate by, say, 2035. So it's still, in that scenario, there's still an awful lot of plastic going to other fates, mainly landfill. And the other aspect of that is that on an annual basis, for every ton of plastic that goes into use in Australia, about 700 kilos reaches end of life. And the difference there, the 300 kilos, that's what's tied up in increasing stocks, as we call it. So that's, increasing numbers of cars, increasing number of cars, but with a high proportion of plastics in them, just increasing products in use, basically. And that 30% difference has to, or under that scenario, is always supplied with new virgin plastics. So there's always quite a big gap between what's recovered and thus can be returned back into consumption and substitute for new resin, even at 2050. So 2050, you've got what, a 50% recovery rate. So you're recovering around 400 kilos of consumption. And so even at 2050, you still need 600 kilos of virgin plastics, probably a bit more, to just supply the demand for new products. The other aspect of that possibly surprisingly low difference is that most of the recycling there is assumed to be mechanically recycled, and mechanical recycling under the current energy mix is about, not even on a 20-year basis, is about half as carbon intensive. So even recycling plastics and getting them back into similar products, back into the system, it still has a reasonably significant, quite significant carbon emissions associated with it. Where the game really starts to change is when you start to combine different actions. So combined scenario one is where you where we've assumed a 10% reduction in consumption and also 100% renewable energy system and 100% recycling. So when you've got 100% recycling and it's all totally renewable, by 2050, you start to get really significant gains in reductions of carbon emissions. But we've got to get from where we are now to where we are there with significant carbon emissions all the way, and in aggregate, that's what it looks like. Look, and I think that's it from me. I think I've run a little bit over time there. Apologies.
Pretty much perfectly on time. Amazing work. Thanks, Kyle. And thanks for taking us into the depth of that research. That's really good to get under the hood of some of those headline figures that folks will have seen in the summary report and in the news articles that were reported. So now I'm going to pass on to Kate Noble at WWF Australia, who's going to give us a bit of an insight into what the policy implications of some of those findings are, and I guess the top line of what this means in terms of what we need to do about plastic in Australia to start bringing emissions down in a meaningful way and what that might look like in a policy context. Over to you, Kate.
Thanks, Shane. And I think, thank you very much, Kyle. It was so useful to kind of dive into the findings in that to that level of detail. I wanted to take a bit of a step back and kind of contextualize those findings in terms of some of the recommendations that Blue Environment made coming out of that study, but also to explain a little bit about why we wanted to look at these policy scenarios and what the research has kind of told us about what those policy scenarios would look like. So to kind of move from quantifying the problem, what we wanted to do in addition to quantifying the emissions resulting from Australia's plastic consumption now and in the future, we wanted to also look at a number of policy scenarios which are really policy outcomes and what that would do to the emissions profile from plastic consumption both now and going forward. And as Kyle outlined, we looked at a number of groups of policy scenarios. We looked at business as usual, what consumption reduction, what kind of impact that would have, increasing recycling, shifting to renewable energy, and a combination of those scenarios. And as Kyle mentioned, we looked at kind of a range of rates or scenarios within those groups to really test out what that would do to the emissions profile. I think we'll move on to the next slide now, Shane. And while we're doing that, I'll just explain, a bit of background. Those policy scenarios don't kind of indicate or go into the level of detail of how to actually, what are the specific policies and measures that would achieve these policy scenarios. They just really kind of talk to, what would happen if we reduce consumption by 10%. We didn't look at, and another piece of work really, and there's a lot of great research out there already on this, is what are the specific levers, whether they be kind of taxes, extended producer responsibility schemes, etc., that would drive that consumption reduction or drive that increase in recycling. So when we look at, this is one of the charts that's drawn from the policy summary that WWF and AMCS produced, and it really provides a snapshot of how those policies scenarios perform. For the full version, that's available in the full report, which maps out a bit of a snapshot of a selection of some of those scenarios in this simplified chart. We can see that the consumption reduction scenarios perform quite well. You can see on the right-hand side that we've got business as usual, kind of, as Kyle outlined, performing the worst in terms of emissions. Consumption reduction scenarios performing quite well, renewable scenario performing moderately well. But as Kyle has just unpacked, recycling on its own, even at 100%, only performs marginally better than business as usual. And perhaps unsurprisingly, it's the combined scenarios that deliver the greatest benefits in terms of emissions reduction. So that's looking at changes and shifts right from reduction of consumption through to increased recovery and recycling, shifting to renewables, and really kind of driving that systems level change as opposed to looking at one specific measure or one specific area for improvement. Next slide, thanks, Shane. These are the recommendations that were delivered by Blue Environment as part of that kind of overarching report. And I've just pulled out again here on the right-hand side some of the charts that that we've included in the summary report. So this looks at the emissions profile of, for example, virgin fossil plastics compared to recycled and plant-based on the right-hand side, and that's in terms of manufacture. And then on the bottom on the right-hand side, looking at end-of-life fates and comparing some of the emissions profiles of those. So there were 6 key recommendations coming out of this work. One was the importance of reducing plastic consumption to avoid the business as usual kind of trajectory that Kyle previously spoke to. The second was a rapid transition away from fossil fuel-based plastic, to shift towards plastic production and management using renewables rather than the current energy mix, prioritising reuse, repair and maximising recycling at the end of life. The fifth, avoiding incineration as a management option. And the sixth really speaks to the potential for global measures to address plastic consumption and also drive circularity and recycling, not just within Australia, but taking into account the fact that plastic production, consumption and management, much of that, well, all of it occurs within a global market. So those global measures or global rules are potentially really important levers in addressing this problem. And I think just coming back to these charts, you'll see that those recommendations really speak to, in terms of the top infographic there, reducing what we see on the left-hand side, so virgin fossil plastics and kind of bringing those emissions down. And on the bottom, it's really looking at shifting away from those emissions intensive management options on the right-hand side, incineration and energy recovery, towards recycling with a preference for mechanical and the kind of the less emissions intensive options on the left. I think what's really interesting and perhaps not surprising is that a lot of these findings map really neatly and logically onto a waste hierarchy approach and the principles underpinning the waste hierarchy, and also a circular economy approach and the circular economy principles, really. So what's really pleasing is that these options aren't there is not a huge amount of tension between what these recommendations are from an emissions perspective, which of course is only one aspect of the issue, and some of the the measures and the needs kind of around shifting the way we consume, produce, reuse, recycle and repair from the perspective of the waste hierarchy and circular economy as well. Shane, could you move on to the next slide, please? So as I mentioned, those policy scenarios really look towards outcomes and what we could, the specific policies or the levers to achieve those outcomes was not the focus of that study in particular. But certainly part of the utility of this study from AMCS and WWF's perspective has been to kind of map these findings onto some of the policy work that we've both been doing in plastics in relation to consumption, production, and end-of-life management for the past couple of years. So, we know that there's a very good evidence base supporting certain types of interventions and policies that could reduce, for example, plastic consumption and increase our rates of reuse and recycling. And we're at a really exciting and pivotal time in relation to this as well, not just from an Australian perspective in terms of some of the domestic reform that's happening at the moment, but also in terms of the potential for global measures to be developed over the next year and a half via a UN plastic pollution treaty. So just to touch really quickly on some of their policies or measures that WWF and AMCF believe that really should be on the table as we move into kind of a policy agenda really focused on packaging, but also more broadly on recycling in Australia. Policies to reduce virgin plastic and or virgin material consumption are going to be really important. Mix of carrot and sticks will be required. So looking at a range of incentives as well as disincentives or penalties to help kind of shift and change the market. What we really need and what we have not had a lot of in Australia over the past decade, we've focused a lot on recycling, but really scaling up our reuse economy, looking at pre-fill, refill and repair and how to drive those kind of types of measures. Packaging reform is a process that is underway and provides a really important opportunity to address some of these issues. And within that, reduction and reuse targets would certainly be something that we would advocate being looked at very strongly, certainly are in other jurisdictions around the world at the moment. And just finally, to touch very briefly on the global potential global measures that could be included in the UN Treaty on Plastic Pollution that is currently being negotiated by UN member states. That process will unfold, has begun already and will unfold over the next year and a half. The mandate of that process, of course, what the eventual treaty looks like is subject to negotiation, but the mandate for that process is to look at the full life cycle of plastics, right from extraction, production, through to use and end-of-life management. So it really could help to shift the dial on some of these issues around, production, recyclability, recycling, design for reuse and repair, etc. There is very strong support for global rules among around 130 or more than 130 UN member states. So that's a really promising start. And potential to deliver emission savings as well as plastic pollution reduction, which is really the main focus of that particular instrument and that negotiating process. I might hold off there because I do know we've got quite a few questions to get to. Thanks very much, Shane.
Fantastic, thanks, Kate. So we're going to move into the Q&A component of this now. And so we've got a few pre-prepared questions that I'll pitch to the panel list to start off with. But if you have questions, please also use the Q&A function as well to submit your questions. There should be a Q&A icon in your webinar toolbar. So have a look out for that. That's the best way to ask us questions. I'll just get everyone's video back up so you can see our beautiful faces. And I might actually stop sharing the screen so that you can see us properly. Beautiful. Hello, everyone. All right, so the first question I've got here is from Monica. And I might pitch this to you, Kyle. In the analysis, do you look at the entire life cycle of material and the emissions of alternatives? Now, I know you touched on this a little bit, but for example, why is it complex for us to look at the total economy of plastics, I guess, and then to compare that against other materials? What's the complication there, and why? What did we focus on in this report?
So it's complicated because we're looking at system change alternatives, and at the moment plastics are pretty much sourced from fossil carbon out of the ground, little bit of recycled content, tiny amount of biomass-based content, and that's it. So it's, and then at the other end, at the end of life management end, there's we modeled 6 different fates that plastics can go to, and they management fates, and they each have their own different characteristics and then emissions profiles associated with that. So this study was possibly more complicated than it looked, or not, because we had to pull that all together in a cohesive framework and then map it onto the plastics flows data as well. we probably made it more complicated for ourselves, and maybe, I don't know, I think it was a good thing. But we also included the for carbon sources, we also included a theoretical source of CO2. So plastics are on average about 75 to 80% carbon, and CO2 is the problem that's being looked at in this study. So it made sense to have a look at what the pathways were for converting CO2 to precursor chemicals for plastics production. They, and especially, and there's sort of three main pathways to do that, which have, differing levels of actual commercial, reality right now, and they all rely upon hydrogen. It's all about reacting CO2 with hydrogen to make the precursor chemicals, to make a whole range of materials, but in particular plastics. And so we thought that was worth unpacking in this study and looking at and there's been there's quite a few LCAs out in the literature looking at how carbon emission intensive it is to make plastics from CO2 and hydrogen. But they, the difference with our study, which probably is, I'm sure it's in the literature somewhere, but the difference in our study is we packaged it all up, and we also made it explicit the difference between making hydrogen from effectively methane and making it from renewable sources, so green hydrogen, and what the difference was between those two. And at the other end, probably one of the more challenging areas of the study was unpacking the chemical recycling of plastics. So there's been a lot of talk around chemical recycling plastics, but when you actually start looking at it at a polymer level, it's quite diverse. They're quite different processes. So, for example, there's quite semi-commercial chemical recycling processes for PET, which are solvent based, and because they're those processes are quite low temperature, low pressure. The solvent can be recycled, and so they seem to be pretty robust, against in relation to additives in PET. So they could potentially handle polyester in clothing. But in any case, what that means is that chemically recycling PET using the processes that we modelled is actually quite a bit less carbon emission intensive than sort of the major processes that are being commercialised right now for chemically recycling polyethylenes like HDPE, LDPE, polypropylene, because they're much higher temperature and they have these quite big, 15, 20, 25% losses of carbon to the atmosphere as embedded in them. And they operate at like hundreds of degrees, high pressure. So they're much more carbon intensive to do. So yeah, what was the first part of that? Anyway,
no, I think
that's a bit of an overview of what
Yeah, so I mean, as you say, the modelling that was required to do this work is quite complex. I mean, maybe Kate, if you could comment a little bit in terms of, we've got some questions from the audience in terms of how, if we're eliminating plastic in selected applications, how do we ensure that the alternatives don't result in a higher climate change impact, or what further work needs to be done in that kind of space, in your opinion? You're on mute, sorry, Kate.
Thanks, Shane. Any kind of reduction measures really need to be combined with robust measures, whether they be regulatory or non-regulatory, to ensure that the reduction that needs to happen in plastic consumption only results in substitution with other materials where absolutely needed. So this is going to be a really tricky problem and transition to address. But what we do know from a lot of great modelling and research that has been done is that it is very possible to significantly reduce plastic consumption before you need to start looking at substitution for other materials. And then when you do start looking at substitution, it is really important to prioritise substitution with non-virgin and readily recyclable materials. It's also really important to combine that approach with one that prioritises and incentivises significant scaling up of reuse, provide, design standards, etc., and incentives around durability of products, and shifting towards a sharing economy and a leasing and a renting economy rather than buy, use, dispose economy. So there is a really broad range of kind of policies that need to be part of the mix. And if we don't have kind of a clear set of rules and requirements that are driving this process, then the reality is that we will probably see a shift to some applications and materials that are more carbon intensive than plastic. So that's why, this really kind of robust approach needs to be taken to this problem, to really manage that transition effectively and ensure that, there is a significant reduction of all materials, and that substitution process is really effectively managed.
Thanks, Kate. And I guess that does sort of come to, one of the heart points that sort of came up in this research, which is that, one of the big reasons that emissions will escalate unless policy measures are implemented to reduce it, is that the consumption of plastic is set to escalate so dramatically. And I suppose further to that, we've got a question from Roxana here, which asks, how does Australia compare to other countries in terms of its plastics consumption and its climate impact? Maybe Kyle, do you want to start on that, and we can pivot to Kate if we need.
Yeah, so plastics consumption is pretty closely, not entirely, but pretty closely related to GDP. So just basically, the wealthier you are, the more plastics you consume. Is a bit of a rule of thumb. Yeah, we're a high per capita plastics consuming country. I haven't seen any figures on where we compare, but yeah, we'd be right up the top of the list just because just because of our per capita income, and we're a developed world country that consumes a lot of plastics in all the goods that we goods and packaging that we use and buy.
Kate, did you want to add anything to that?
Oh, and just in terms of the carbon intensiveness of our packaging use, sorry, we're just the same as everyone else. So if we use 2 kilos of plastics in the products and packaging we use, and another country in the Pacific or something uses 1 kilo, we're just that it's putting aside a little bit of difference in the transport implications. We're just using we're emitting twice as much CO2 into the atmosphere.
Thanks, Carl.
I guess it's just worth flagging Mindaree's modelling around the amount of single-use plastic waste that is generated per person in all countries around the world, and then the comparative work that they've done around that, which put Australia second to Singapore only in terms of single-use plastic waste generation per person. So that is a pretty significant kind of league table that we should definitely not be proud of being placed in the top 3, really.
You're right.
Cheers. So there's also a question here from Ella. Are there innovative or newly researched solutions for decomposing, breaking down plastics that don't result in microplastic problems? Now, I might actually jump on that one from a marine conservation's point of view, because it's actually quite a critical one. One of the things that the research showed is that moving towards plant-based plastics is less emissions intensive. But of course, being less emissions intensive doesn't necessarily mean that a plastic is still a good thing to use. So what we do know, for example, is that composting of PLA still results in emissions. But also what we know as well is that not every plant-based plastic breaks down if it ends up in the ocean, and it doesn't necessarily break down quickly. So for example, I do know that we've seen some early insights from a major study in Southeast Queensland's Moreton Bay, which shows that PHA plastics that are bio-based will take about 7 months to break down in the ocean, but other bioplastics will degrade by as little as 1% per year, is some of the early insights from that research. So I guess it just comes back to that point of, you know, if it looks like plastic, it probably is plastic, and it doesn't mean that it's going to, just because it's bio-based doesn't mean that it will break down quickly in the ocean. And that kind of, I think, brings us back to that broader issue of, I guess, cutting plastic is not just about reducing emissions. It's also about dealing with the fact that we have so much of it leaking out into our natural environment and the environmental costs that that has directly on wildlife as well.
Yep. And just look further to that, if you looked at the plastic applications in all the plastic products and packaging we used, and quantified, what proportion of those are suitable for shifting from conventional plastics to fully certified compostable plastic packaging, plastics across products and packaging. Look, I haven't calculated that number myself, but if it was more than 10% of consumption, I'd be stunned. You can't incorporate certified compostable plastics into car panels, for example, and then paint them. You can't make a kid's footy out of, certified compostable plastics that isn't coated with something that isn't then compostable. Just so many of the products that we use, just it's hard to imagine how they could ever be accepted going into a composter's gate, and they'd be happy about it.
Thanks, Carl. That's a very good point. So we've had quite a few questions around the policy measures. Michelle asks, where are our state and federal governments at in terms of implementing policy to legislate, ban, enforce those bans, etc., move towards closed loop circular economy. But also we've had questions around, what requirements are there currently on companies to stop wrapping everything in plastic? We've had a few questions relating to fresh produce, magazine wrappings, the medical sector. So I guess I'll just wrap those up in, one question to you, Kate, which is, what is currently being done to require companies to bring down their use of plastic, and what do we think needs to happen to really change that at the moment?
I'm going to try and wrap it up on an optimistic note, and then Shane, it would be really useful to hear your reflection on where things are at more broadly. Look, I think over the past, particularly 5 years, we have seen a really significant policy shift in relation to plastic consumption and waste management, and the amount of plastic waste that we produce, and the amount of pollution that unfortunately results from plastic entering the environment. I think the groundswell has been really significant in terms of how engaged people and communities and businesses are in this problem and wanting to find solutions to this problem. And I think that in turn has driven a real some really substantial policy shifts right around the country, from local government level through state and territory, through to a national level. And so a lot is in train. There's a lot more that needs to be done, and a lot of kind of particular measures, particularly economic measures around incentives and disincentives to kind of do more of the right things and do less of the wrong things, if I can put it in those simplistic terms. So, that's something that we need to be doing more of and looking very seriously at, because you're not going to shift plastics markets if you don't kind of deal with those economic issues and the problems within that system that are fundamentally based on economics. But we've seen a big shift. And we've seen that largely driven by people and communities that care very deeply about this issue. And that's really positive. There are now, opportunities around the domestic reform, around packaging, recycling, reusability, for example. And there are huge opportunities in the international space as well. So I think that's a really positive thing. Shane, how do you think we're tracking?
It's a good question. I think, as you say, there's been some really significant shifts in even just the last 5 years, right? We've had bans on single-use plastics rolling out across states and territories across Australia, and a somewhat exciting race to the top between many states, almost out-competing each other to see who can tackle more plastics in their bans and phase-outs, which has been really good to see, and a sudden and very rapid shift over the last couple of years, which is starting to have Australia look quite positive on a global stage when it comes to phasing out plastics. We've also had real success in terms of getting container deposit schemes around the country to increase plastic bottle recycling rates, and those have been very effective. And I guess that comes back to that incentive model, right? When there's an economic incentive to make sure things end up in the right recycling stream, people really get involved, which is fantastic. But I guess, what is really clear, if we look at the rate of at which plastics is going to increase, and we'll see globally plastic production double over the next 20 odd years, and the amount of plastic leaking into our oceans triple, much more significant action needs to happen in terms of bringing down the amount of plastic that's leaking into the environment, and then of course dealing with the emissions that are associated with it. And as you say, we need to, I think AMCS is very firmly of the view, particularly based on this research as well, we need to reduce the use of packaging, move towards reusable systems rather than just relying on substitution, because of course that also has an emissions impact. But where we are using materials such as plastic or other materials, we also need to think about whether they will degrade quickly if they are lidded. And that's why, for example, paper is often a preferable option to, say, a plastic if it ends up in the ocean. So there is more that needs to be done. We desperately need regulation of the use of plastic packaging in Australia, I would say. We really need that global treaty. But we are in such an exciting time that both of those pieces of really critical reform are on the table right now. So I don't know, I too feel a little bit optimistic in terms of, we're facing a huge crisis, but we're in a really pivotal moment in history, and it's a really exciting time to be involved in this work. So we're just reaching the last couple of minutes, so I might just ask one more question. And I'll pitch this to you, Kate. What do you think is going to be the biggest challenge in getting governments to move quickly enough? That's a really hairy question, I know, but I guess it comes back to what people can do to help, I guess, and what we as organisations need to be doing to help our governments come to the table and getting the action we need.
Look, I think the next iteration of what needs to happen is really challenging technically and in terms of kind of working out where we want to go and how to get there. Single-use plastic bans are not that hard to do. I think, this next phase around how to increase circularity and, put together a kind of suite of design standards and certification standards. This is all like, this is the nitty-gritty and the hard work. Whereas, the sort of single-use plastic bans that looked at eliminating the most harmful and problematic plastics when they do leak into the environment, that are the biggest risk in terms of leaking into the environment, that was actually quite low-hanging fruit. So it's great that that's happened. I think the next phase is much trickier.
Thanks. One thing I would note for those on the call is the proposed packaging regulations that are, I guess, on the table. We understand that the government has a plan to release those to public consultation either towards the end of this year or early next year. So I'd say that that's something for everyone to be keeping an eye out for as well, because there's going to be an opportunity for us to feed into those, both as community members or as organisations involved in this space, and to reiterate the need for us to have concerted and sensible action on this. And so we encourage everyone to look out for that as well. All right, so we're going to wrap it there. Thanks to everyone for taking the time to join us today, and for listening as we take a deep dive into the research and what this means. Obviously, we did not have time to get to everyone's questions, but we really appreciate you popping them in there, and where we can, we'll see if we can get some responses out on those. After this, the webinar recording will be uploaded to our YouTube channel, and we'll seek to send an email out to the registered attendees with the link to that so that you can watch it later if you need. Thanks to Kate and Kyle for joining us today. Really appreciate having you. And I hope everyone has a wonderful afternoon. You will also get an end of webinar survey once we close this out, and we'd love a little bit of your feedback so we can make sure that these kinds of sessions are as useful as possible.
Great.
Thanks, everyone.
Thanks, Shane. Thanks, Kate. Cheers. Thanks, everybody.